अच्छा कुमार मुझे पर्सनल मैसेज करता, गुड मॉर्निंग। अरे गुड मॉर्निंग कुमार, तो नाम ही चेंज कर देना मैं। So guys, now the thing is that we have a routing protocol, right? And in this routing protocol we have a two types, as we know that one we have a static or one we have a dynamic, right? One we have a static, not protocol, so static or dynamic. In itself, in a dynamic routing protocol, what happened, we have a two types. One is IGP protocol and one is BGP protocol. Not BGP, it's IGP or EGP, right? Under the IGP protocol we have a RIP, IGRP, EHGRP, OSPF, ISS protocol, right? These are the protocol that belongs to the IGP one. Under the BGP EGP protocol we have a single protocol that is known as a BGP. Under the EGP we have a single protocol that is known as a BGP protocol. Now the first question comes in the mind, okay, the routing has a two types. One is the static routing. In the static routing, what happened, this network engineer has to be involved for every destination, right? If you have a thousands of the prefix, this network engineer has to define the thousands of prefix on a single router, right? In a dynamic, what happened, I'm going to use the any routing protocol. Either we can go for the IGP or either we can go for the EGP one. Now the question is that if you already have this protocol, then why do we need a BGP? The thing is that if I'm going to tell you, if this is my R1 router, this is my R2 router, and this is my R3 router, and there is a one subnet behind the this PC1 behind the R1 and PC3 behind the R3, right? And for example, this is Kumar, and Kumar wants to talk with the Nidhi, right? So what happened? If you know provide the communication between this two subnet 1.0.0.0 to 2.0.0.0, and we have a 12.0 subnet, we have a 23.0, we can achieve the communication between these two person, right? We can achieve this communication between these two person by just applying the other RIP, IGRP, EHGRP, OSPF, and ISIS, right? If I'm going to enable the EHGRP on this guy, and this guy, they can exchange the route, right? Then why do we need a BGP? If you already have a IGP protocol, then why do we need a BGP, right? Now, to understand this thing, let's come to the this topology. Why do we need a BGP? This is my router number one. This is my router number two. Okay, and this is my service provider network. So this is my router number three, right? 4 and 5. Then we have another customer. We have this guy and this guy. Whatever the protocols we have right now in the IGP, we have a either we can go for the OSPF, EHGRP, RIP, or ISS, right? Or either if you're not, you can run the static router as well as R1, R2, R3, R4, R5, R6. If you understand this concept right, your BGP will be complete. I'm telling you. You need to understand this basic concept right now. This is my 12.1 IP address. Sorry, 13.1, 13.3. This guy 23.2, 23.3. And this is the 34.3 and 34.4. 45.4 and 45.5. 56.5. 56.6. 75.5 and 75.7, right? This is my customer, network home Delhi, right? Network home Bangalore. We have another company, Nokia Delhi. Nokia Bangalore. Try to understand. ये बात करवाता है बंदे से 1.0.0.0/8 over there, right? Behind the R1. Okay, we have a LAN information over there. We have a LAN information 6.0.0/8 over there. Then after that, we have a 2.0.0.0/8, and we have a 7.0.0/8. As I told you that this is my core service provider network, right? Core service provider, right? Till this point. Clear? Now, this is a service provider, and what is the use of service provider? To just provide the service to the customer. The use of service provider to provide the service to the customer, right? So how many customers we have right now? Network of Delhi, and we have a network of Bangalore. We have a Nokia Delhi, and we have a Nokia Bangalore. Of course, this service provider is going to run with any of the routing protocol, right? So it will take any of the routing protocol from this range. Either it can move for this OSPF, EGRP, RIP, static, or ISS protocol. So right now, this ISP saying that, hey, I'm going to run with the OSPF number 1, right? Now, this between this link, right, R1 and R3, this guy saying that, hey, I'm going to run the RIP protocol, right? Between the R2 and R3, this guy saying that, hey, I'm going to run with the EGRP number 100. Between this guy is saying that, hey, I'm going to run with the EGRP number 200. Or between this guy and this guy, he said that, hey, I'm going to run with the any of the routing protocol ISS, because you can choose any of them, right? This person can choose any of the routing protocol. It's totally depend on the customer by customer, right? Now tell me one thing. When R1 will configure the RIP protocol on a router number 1, it will put the command router number 1, RIP, and it will advertise the network 13.0, and it will advertise the network 1.0.0.0. What R1 will do in this case? R1 will share this information to whom? R3. R3 will receive this route. And what R3 will do? It will put this route into the routing table, right? So R3 routing table, we have something like this. RIP 1.0 AD some metric. Next hop will be 13.1, and I'm learning this interface on 0/0, right? This interface. Same thing. I'm going to configure router EGRP on R2, right? Once I'm going to configure the router EGRP on R2, R2 will share the own information to the R3. So basically what happened, R1 is sending this information to the R3, and R2 is sending this information to the R3. What R3 will do in this case? R3 will maintain this route in the routing table D, some AD values, some metric over there, 192.168.23.2, and I'm loading this information on 0/1 interface, right? And this route is known as a which route? Internal route. Why? The AD of this guy is 90. So EGRP, we have 3 types of route. We have summary route, we have internal route, we have external route. Summary route AD has a 5. Internal route AD has a, external route AD has a, what is the AD? And it's a local, it's a trustworthiness of the route, right? And it's a local to the router. Now, guys, once we put this information in the R3 routing table, this interface, listen to me, gig 0/2 and 0/0, 0/1 and 0/2. All this interface is running with the which routing protocol? OSPF, right? Will R3 send this information to the R4 by default? No. It can't say, right? Because we are learning this information from the RIP protocol, and we are learning this routing, this information from the EIGRP. So by default, R3 will never ever share this information to the R4, never ever. So what we have to do over there? Redistribution, right? So what we have to do on a router number 3, on a router number 3, I need to say that router EIGRP, or we can simply say that redistribute this route from RIP protocol into OSP. Then redistribute route from EIGRP 100 into the OSP. Then now once we perform the redistribution, what happened? Now R3 will send this information to the R4. R4 will maintain this information in the routing table as a E2 dot and E2 dot, right? Same thing, R5 will also maintain this route in the routing table. Clear? Now once R1 will share the own information to the, not R1, when R3 will share this information to R4 and R4 will share this information to the R5, R5 will have this information in the routing table. Will R5 share this information to the EIGRP 200? By default, not. So what we have to do in this case? On a R5, into redistribute from into, done. Perfect, right? If you want to provide the communications, if you want to provide the communication between the network of Delhi to the network of Bangalore and Nokia Delhi, Nokia Bangalore, or Nokia Bangalore, Nokia Delhi to the NH Bangalore, we need to exchange the route, right? We need to exchange the route. So on a R5, I did this redistribution. Now R5 will share this information to R6 and now R7. Done. So now in this R6 routing table, we have this information, right? Right. Now what we have to do in the next case? Now R7 will advertise own information to the R5, this information, right? And R6 will advertise the own information to the R5. Which information? This information. R5 will receive this information in the routing table. He said, okay, let me have 7.0.0.0, right? Via the EIGRP, right? And for the ISS, I'm going to run with the done. Will R5 will share this information into the OSP by default? So what we have to do on R5? Redistribute route from OSPF number 1 into OSPF 1 route from into, done. So now once R5 will redistribute this route, what happened? R4 will maintain this information as E2, as the E2, right? Because R5 is now sharing this information to whom? R4, and now R4 will share this information to the R3. So R3 also have this information in the routing table, right? Will R3 will share this information on RIP by default? No. So what we have to do on R3? RIP into, done. So now this guy will share this information to R1 and R3 will share this information to R2. Now this guy has the information about this network. and this guy has info on this network, right? How many companies are there right now? Two companies, but multiple branch, right? How many redistribution we are doing on R3? 4. How many redistribution we are doing on R5? Can you imagine if you have a thousands of the company, how many redistribution we have to do? Multiple, maybe the 10,000, 2,000, 5,000, right? Depend on the requirement. If you have a, just take example, if you have, each company is going to have a 5 branches, right? Or in the future branches will be increased, right? In future branch will be increased. If the companies has a multiple branches, in that case, what happened? This router and this router, whatever the edge router, provider edge, P means what? Provider edge, because this router is going to provide the service to the customer, right? So all this provider edge router is going to maintain the huge amount of redistribution command. So can you imagine whatever the running config of R3 and whatever the running config of R5? In just a 2 case, what happened? I have a huge range of commands over there. And if you have thousands of the company, in that case, you need to maintain the huge amount of redistribution on a R3 and R5 running config. This is the first issues. Second issue, if I'm going to talk about, this is the first issue, that you need to perform the lots of redistribution on this router R3 and R5. Second issue, on which routing protocol OSPF, sorry, on which protocol OSPF works? IP 88, sorry, 89, EHGRP, RIP. I forgetting the, I'm not sure which is the ICE is there, right? Static is static, right? Is there any protocol is reliable over there? What is a reliable protocol? TCP. Second thing, RIP, EHGRP, OSPF is not a reliable protocol. I'm not so not reliable protocol. It's not using the reliable mechanism because it works on UDP or IP. Whereas BGP is only routing protocol that works on second disadvantage. Third, do you know, if you see the name over there, what name is signet? IGP means what? Interior Gateway Protocol. What is the meaning of EGP? Try to understand. IGP is only implemented within the enterprise network. Or we can say that company network. Whereas EGP is implemented within the company and between the company. I'll let you know the reason, don't worry about that. Thing is that, take example, this is the one home, right? Gupta house. This is the his father, mother, brother, and sister. If they wants to communicate to each other, they can use any IGP. IGP means what? It's an interior, right? Interior means what? Within the home. Interior means what? Within the home. Sony's family also have a father, mother, sister, and brother. If they wants to communicate to each other, they can use any of the routing method. For example, they can use for the EHGRP, or this guy going to use the OSP over there. So within the companies, right? Within the company, we can use any of the routing protocol. That's the IGP is the name suggesting that. But if I'm going to talk about the between the companies or between the home, we always going to use the reason is very simple, because whatever the IGP protocol we have, they don't have a ability to maintain the thousands of the prefix. IGP is not so scalable. Right now on the internet, how many routes are there? Can you imagine? 32 bits of the IPv4 is almost done, right? Now we are using the IPv4, sorry, IPv6. So this IGP protocol is not so much scalable to maintain the huge amount of routes. They can just maintain the 1000, 2000, 3000, max to max 5000. This guy does not have a much ability. That's why we have introduced the BGP. BGP is so much scalable. Right now, the complete architecture of internet is totally depend on the BGP protocol. It's totally depend on the BGP protocol. And this is not a new protocol. I'll tell you those things. This protocol has introduced in the 90s. Still we are using for the internet architecture backbone. This is the backbone of the internet right now. Third thing is that another thing is that it's not so scalable. IGP is not so scalable because they don't have ability to maintain huge amount of route, or we can say the prefix. Right now, third thing is that, tell me one thing. If I'm going to tell you router number 1, router number 2, router number 3, router number 4, right? We have some network behind the R4, right? What I'm going to run with a protocol like a EHGRP over there. I want to make R2 as the best. Tell me, how do I do that? I need to do the path manipulation, right? If I'm going to tell you, hey, I'm going to run with the EHGRP on a R1, R2, R3, R4, and what I want, whenever R1 will send the traffic for this guy, 4.0 is coming via the R2 and 44.0 is coming via the R2. R3 should be as a backup. This should be a primary and this should be a backup. How do I do that? In EHGRP. In EHGRP, either you can change the bandwidth, delay, either you can go for the offset list, and either you can go for the AD values, right? That's it. If I'm going to talk about the OSPF, then cost. If I'm going to talk about the RIP, hope can't. Anything else except this thing? No, right? Now, from one location to another location, how many paths we have? Multiples. It's just a small example, right? It can go by like this, 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 right? Multiple paths. Tell me, if I'm going to implement the IGP protocol, how many ways we can manipulate the path over there? One or more, max to max two, right? One or max to max two. What BGP allow you? You can manipulate the path almost, according to your syllabus, almost 11 ways. It can have 13 and 12 as well, as that has a very high level things, right? You can manipulate almost 11 ways. They have a rich amount of attributes, and based on that attribute you can manipulate your path. That IGP is not so scalable over there. If you are going to implement the EHGRP, you just need to have a delay and bandwidth. OSPF just have a cost over there. BGP almost have a 11 ways. Except this thing, we have another thing as well as, but most popular is 11 ways. If you go for the more and more deeper of the BGP, you will see that we have many things to manipulate the path in the BGP only. Fourth thing is that, take example. Meanwhile, I'll show you something. Recording pause again. The recording pause. Just read this line from here to here. Right? So now if you see the keep alive message, do we have any information on them? As compared to the hello packet of OSPF, can you see that the difference? See the difference is happening. Keep alive is just totally empty packet. No information are even present, no single information. Because in BGP, what happened, we have a separate packet for the neighborship and separate packet for the maintaining the neighborship. But in OSPF EHRP, what happened? We are going to same packet for the maintaining the neighborship or forming the neighborship. This is the reason why we are not going to prefer the IGP protocol on the internet side as well. So what happened in this topology, guys? In this topology, if I'm going to implement the, or another thing as that, another thing, take example. In this case, what happened? The R4 is the router, right? R4 is a core router, right? What R4 is doing over there? Maintain the routing table information. Maintain the routing table information. By using the BGP, you can indirectly form the neighborship between R3 and R5. In that case, this information should be not there. So we can achieve a BGP free core topology. Free core means what? R4 does not need to maintain the routing information. Can you believe what happened? A single route is going to contain the 200 bytes of memory of the router. Single route, almost. So if you have a 100 plus router in the core network, right? The core network R4, they don't need to maintain the BGP routes. If you're going to implement the BGP over there, and by implementing the BGP, what happened? If I'm going to run the BGP over there, inside the service part, I'm going to run the OSPF on this guy, on this particular link, this particular link. So this particular link is I'm going to run the OSPF, right? Under this company, I'm going to run the OSPF over there. But between this company, I'm going to run the BGP, 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 and BGP. And over the link we have, I'm going to run the BGP. Do I need any kind of redistribution on a R3? Same protocol, nothing. So no need to put this amount of configuration on the edge router. Does R4 will maintain the routing information? No, I can directly exchange my all this information through the R3 and it will say through the BGP to the R5. Directly from one edge router to the another edge router. R4 no need to maintain this router. I can make a BGP free code topology over there. This is the benefit of the BGP we have, guys. Clear? Why do we need a BGP now? This is the reason why do we need BGP. BGP is so much scalable on the internet side, so much scalable, right? But there's a requirement of the BGP, a very basic requirement that you need to know to implement the BGP in a production network, right? To implement the BGP in the production network, the minimum requirement is that to store the complete global BGP routing table from one BGP peer, it is best value to minimum have a 512 MB RAM or 1 GB RAM in the router. I'm again repeating, I'm not discussing with the practice purpose. On a GNS3, if you see this router, what is the RAM? 128 MB, right? I can run the BGP on this guy. There is no issue. I'm talking about the perspective of the internet side. If the 256 MB RAM is used, it is recommendation that you use more route filtering over there. If you use the 512 MB RAM, more internet routes can be placed in the routing table with the fewer filter. On the catalyst, this amount of switches full BGP table is recommended to have a multi-layered switch features card over there. So the thing is that at least on a production side, at least you need to have a 256 MB RAM, at least minimum requirement. But still in this case, what happened? You need to perform the filtering. This is the prerequisites to run the BGP on the router. I'm again repeating, I'm not discussing with the perspective of the doing the lab in laptops or on the real racks. I'm doing the I'm telling you the perspective of the production network. Clear? Now, so once the router, now try to understand where I'm going to run the BGP. I'll tell you. First of all, the BGP is the name suggests that. Okay. First of all, we have a EGP protocol. From the EGP, we have introduced the BGP. So how, hi, Law, could you please share those doc? I will share the promo. Don't worry. So EGP and BGP. EGP stand for what? Exterior Gateway Protocol. BGP stand for you know one thing? Before the BGP, we had a protocol that is known as EGP. EGP was a protocol. It's not a name. EGP was a protocol. After EGP, we have introduced the BGP. Because the problem with the EGP, the first issue with the EGP was a and second, for a design perspective, you need to follow lots of rules. Like if you know the OSPF, in a OSPF, what happened? You are following the rules. You can only do the summarization on the ABR. You can only do the filtering on the ABR. For the LSA3, you only have to do the LSA5 summarization and LSA5 filtering on the ASBR router. If you have a virtual link, you cannot do the summarization, something like that. Yesterday we discussed, right? So we have a limitation, right? Same thing as a design perspective, the EGP has a limitation. So after EGP, what happened? We have introduced the protocol that is named as a BGP. BGP stands for, it's a border, right? Border means what? To understand this first term, the border, to understand the first term, the border, what we can do over there, take example, this is my company network, this is a switch over there, right? This is my router over there, connected over there. This is my another router over there. We have another router over there, right? We have a switch connectivity over there and some user are setting, right? Copy, paste. Now try to understand, this is my router number 1, switch 1, switch 2, switch 3, switch 4, PC number 1, PC number 2, PC number 3, and PC number. Now, this is my one organization, right? This is my another organization. Clear? Two different organizations. I say that company X and company Y. Till this point, right? This is my link over there. Do you know, till this point, here to here, right? The green one, and even this point, this side subnet. All this guy is going to run with the any IGP protocol, any of the IGP. Same thing till this point. The green one, we are going to run with the any of the IGP protocol. Either you can go for the OSPF, EHRP, anything. It's totally up to you. But the border means what? Who is the border router of this company X? R3. What is the border router of company Y? R4. So on this particular router, we are going to run the BGP. Here the BGP will run. That's the meaning of border. Border means what? Every company has a one border router, and on that border router, we are going to run the protocol. And that's the meaning of exterior. Company X and company Y, the two different companies are there, and between the two different company, always we are going to use the BGP. That's why the name is saying that it's a border gateway routing protocol, because between the border of the company, we are going to implement this protocol. Okay. Now, whenever you're taking a connection with the ISP, right? Whenever you're taking the connection with the ISP, because every company need a connection with the ISP to provide the internet connectivity or to provide the communication between the multiple branches, right? To provide the communication between the multiple branches or to access the internet, we need to take a help of the ISP. ISP will give you to take a internet connectivity or to provide the communications between multiple branch. For example, you have branch office in the Bangalore, Delhi, Calcutta, Patna, Mumbai. You know, if you need to provide the communication between those branches, you need to take a help of the ISP. What ISP is going to give you? ISP will give you four types of connection, or we can say four types of internet connection. The first, we have a single home. As the name suggests, single home is what? One customer to one ISP. Single multi-home. In that case, what happened? Still one customer is there, but you can have multiple links to the customer, to the ISP. Either you can take a dual multi-home, sorry, dual single home. In a dual single home, yep. In a dual single home, what happened? एक मिनट ना. एक मिनट. Dual multi-home. Okay, single module single home is something like that. One multiple customer, the single ISP, I think so. I don't know. Let me check this. Single home is what? You are connected to the single ISP using a single link. For example, router number 1. Recording is going on. ISP. Okay. Dual home is what? You're connected to the single ISP to the dual links, right? Router number 1. Question is that if you have a single home, then why we have introduced the dual home? Tell me. Single link failure, because in this case what happened, you will have a single link failure. To avoid the single link failure, what we have introduced the concept of dual home. Single multi home, you are connected to the two ISP using the single link like this. R1 ISP1 and ISP2, right? Dual multi home means what? Router number 1, you can use the router number 2 as well as ISP1 or ISP2 like this. Tell me which topology is better according to you. See, I'll tell you, you can implement the BGP on this guy. You can implement the BGP on this guy. You can implement the BGP on this guy. You can implement the BGP on this guy as well. Recommendation, I'm telling you, in this case, no need to have the BGP. You can just use the, if you wanna, you can use the default route. You can also use the default route in the case. Default route also used to help the provide the connectivity, right? I can use it. Either you can implement the BGP in this home mode and either in this home mode. It's a recommendation mode. It's a recommendation mode to implement. See, it's only recommendation. You can also implement the BGP on the single link mode, right? You can also implement the BGP in the dual home, but the recommendation is that you can go for this, because if you're going to take a BGP connection, you need to charge, or you have to charge, or sorry, ISP will charge you lots of money, right? If you need a BGP connection, ISP will charge you lots of money. So tell me which link, which topology is better, this one or this one? Why?
Hey, Law.
Yeah. Tell me.
Your single multi-home can also be with the router R1 going to ISP1 and router R2 going to ISP2, right? Because it does not necessarily has to be through a same router.
Like this, you are saying like this?
No, what I'm saying is your single multi-home, you have a connection from R1 to ISP1 and R1 to ISP2, right?
And like
ISP2
this, you are saying that you can like this?
No, what I'm saying is add router R2.
Okay.
And connect that to ISP2 in your third diagram there, right? Connect router R2 connects to ISP2.
ISP2, then
router R2 connects to ISP2. So this is also example of single multi-home, right? Now R2 does not connect to ISP1. R2 connects to ISP2 and R1 connects to ISP1.
Yeah, exactly right. This is also
so
connection.
This is,
yeah, exactly
so
right.
If this is single multi-home, then I would go with this one. If you were to ask me why, because every time you order a connection with the ISP, you have to pay for the connection, right? So you have a redundancy on the ISP.
You have a redundancy. You have a redundancy of the ISP, but what about the link over there?
So this is what I would do, right? I mean, you have a link in a, from R1 to ISP1. If that's your primary connection, you can make R2 to ISP2 as a secondary. Then you have a link redundancy as well.
Yeah,
So you see
but
what I'm saying?
exactly right. You are right, Suraj, right? But the thing is that,
Mm-hmm.
still you have a single link to the particular ISP.
I agree. That's the reason I have a connection to secondary ISP
Yeah, that's
because
you have
every
a
time
connection with the
every.
secondary ISP. For example, this is my ISP link is giving the 10 Mbps link, and it's my 5
Mm-hmm.
Mbps link because I want to make this guy's a primary. I want to make this guy a secondary, right? And this guy is my primary link, and this guy is secondary link. What happened in this case?
If money is not a concern, I would go with your fourth option, dual multi-home, right?
Exactly
Fourth
that.
option.
That's
If
so
money is not a problem, if money is
exactly. See,
concerning, then I
always
would go to third option.
in a networking, always you have to think the cost. This guy is very, very important.
Yep.
This person is very, very important in the networking service,
Yeah.
right? So that's why always recommendation you can go for the dual multi, because if the company is paying the lots of money, it always has to go in the dual multi. It's not a big thing that it can take a another connection with that person, right? Another link with that connection. It's not a big deal, because if you're paying for the one link, ISP can take another link as well, as right. Killer Peter. ISP, his name is Peter. I think actually his name is Peter or Suraj. Your name is both of them Peter or Suraj?
No, I should be Suraj. Why do you see Peter? Peter is my that's like the ID that I use, but Suraj is
Okay,
my name.
Asha.
I
Okay, sorry,
renamed
sorry.
myself.
Okay, okay.
No
Actually,
worries. I renamed myself. It should be
okay, okay,
Suraj. You're calling me correct.
okay, okay. Right.
Yeah, so that was just my thinking, right? If money is the case, then I would go with the third option because I get a redundancy from ISP perspective, I get redundancy from a link. But if
Exactly.
money is not a concern, if I have plenty of money, then I would go with the fourth option.
So of course, if you're going to take, if you're planning to take a BGP connection, you have to take a, you have to have lots of money in your pocket, right? Then you can,
Yeah.
otherwise you can go for the default route. Now, two tasks you have, guys, right now. You have a two tasks. The first task is that you need to find in which case I'm going to use the default route, or in which case I'm going to use for the BGP. No, I can use the BGP over there as well as I can use the default route as well as. In which case I have to go for the default route. Uh,
So
uh,
one other option, why do you want to do default, is if your router is not capable of doing BGP, right? If you have a pretty low end router and you don't
yeah,
want to take
exactly.
the
That's so one answer. If you have a lower end switch of the router, if they have a lower end switch of the router, you always go for the default route, because as I already mentioned at this point, at least you have a, at least
256 MB RAM.
minimum. But still, in this case, what happened? You need to do the more route filtering of them, right? So take an example. If my router, if my router still have a 256 MB RAM, if my router, this router is a 256 MB RAM, tell me, should I go for the BGP? Think about it. If you have a 256 MB RAM, should I go for the BGP?
you can, but you have to be very selective on what routes you take. You won't be able to take all the internet based routes. You'll have to
Exactly,
limit
right.
yourself.
You have to be selective person over there in that case. And another thing is that, see, default route means what? Default route is something like that. If you wanna reach to the internet, you can use the default route. If you're not reach to, if this person wants to reach to the internet, then you can use the default route concept over there. Take example, if the company has a own subnet, then can I use the default route over there? I, IGP, I cannot use the IGP over there, right? Simple reason is that I cannot use the IGP. So see, reason is very simple. Whenever you're reading something, guys, from the books or anywhere, try to always think the design perspective, right? See, I'm not denying it that you can use the default route over there and you can use the BGP as well as, right. As the Suraj also recommendation that you have to go for the minimum requirement. That's a, if you have a minimum requirement of 256 MB RAM, in that case, also you need to implement the lots of the route filtering over there, and to perform the lots of policy on the router number one. you need to require a good network engineer. At least good network engineer you have to require, because BGP is not like that you can anything you can implement over there, right? You have to always think about the design perspective. Right now, my case is that if you have a own subnet, go for the BGP in this case, because you need to advertise that subnet to the ISP, and whatever the user that behind the ISP they wants to access your server. But if you don't have a internal route and still you have a 256 MB RAM, in that case, do you need a BGP over there? I don't think so, because if you're going to implement the BGP, you need a good network engineer as well as. Clear? These are the small things that you have to be focused. Clear? Thanks. Anyone has a question till this today topic? No? So guys, I'll tell you one thing. Tomorrow onwards, I'm going to start your all the BGP things. So today was just information on how the BGP things are going on and what's the difference between the IGP and BGP protocol, right? So tomorrow onwards, I'm going to, my tomorrow topic is, I'll tell you BGP neighborship, right? BGP neighborship. After the complete the BGP neighborship, then I'll go for the BGP message type or BGP states. Okay. And for this BGP class, I'm telling you, we don't have a time limitation. We'll go for the anything, right? We don't have a time limitation. We're going to go for the any time. I will put the message in the group, right? So tomorrow we have a class same time, 8:15, right? Tomorrow we have a same time class, 8:15 a.m. But with the, from next weekend, the next Monday, this batch will be 8 a.m. We have a switching, right? I will cover the BGP as well as, don't worry about that. Okay, I will put the timing. But this weekend we have a BGP till this weekend. Okay. So I will put this videos in the separate BGP folder. Okay, I will upload, I will say this separate BGP folder to every person. And another thing is that I will save this docs as well as whatever the docs I have for the BGP. Okay, I'm going to say the every docs. So if you have a time, so my recommendation is that if you have a time, okay, please read this book. It's an amazing book. I'm telling you, it's amazing. This internet architecture. I'm telling you, in this book, you will not get any single command. You will some commands are there like how to authenticate the person, right? That's it. But this book is a complete internet architecture. This is going to tell you why do we need a BGP actually, right? So if you have a time, read this book. And I'm telling you, without BGP, you cannot survive in the market. This is a fact. I've seen many of the person, they don't have any single idea of the BGP, and they're working for the organization, but they are not rising in the company right now. So you have to be a little bit more focused on the BGP as compared to the IGP routing protocol. And in a BGP, what happened? Many of the interview questions they are asking for the BGP or path attributes only. How to form the neighborship? What is the neighborship criteria we have? Whatever the path attribute policies. And if you're planning for the CCI exam, I'm telling you, without BGP, you never ever clear the CCI exam. Not security, enterprise. Okay, clip. All good. So guys, see you tomorrow. Bye bye. Suraj, any question to you?
No, thank you. Yeah, I mean, I know I started for switching, but I'm starting from today itself. That's okay, right?
No issue. Thank you.
All right. Thank you,
Thank you. Okay, Sarath. Bye bye. All guys, bye bye.
Bye.
Thanks, bye.